Bloch's method of synthesis from module 3. Bloch, it is the scientist name. He is a Russian kinematician. Bloch's method is one of the method used to determine the length of the links in the given mechanism. Bloch's method discovered the equation L2 equals angular velocity of link 4 into angular acceleration of link 3 plus j into angular velocity of link 3 square minus angular velocity of link 3 into angular acceleration of link 4 plus j into angular velocity of link 4 square. L3 equals angular velocity of link 2 into angular acceleration of link 4 plus j into angular velocity of link 4 square minus angular velocity of link 4 into angular acceleration of link 2 plus j into angular velocity of link 2 square. L4 equals angular velocity of link 3 into angular acceleration of link 2 plus j into angular velocity of link 2 square minus angular velocity of link 2 into angular acceleration of link 3 plus j into angular velocity of link 3 square. L1 equals minus L2 minus L3 minus L4. These are the four equations which is used to determine length of the links in the given mechanism. Here the meaning of L1, L2, L3 and L4 nothing but length of the frame, length of the crank, length of the connecting rod and length of the follower respectively. Similarly, omega 2, omega 3 and omega 4 nothing but angular velocity of crank, angular velocity of connecting rod and angular velocity of follower respectively. Alpha 2, alpha 3 and alpha 4 nothing but angular acceleration of the crank, angular acceleration of the connecting rod and angular acceleration of the follower respectively. Here we can see one of the example for Bloch's method. In the given example, we can see angular velocity of link 2 that is 200 radians per second, angular velocity of link 3 that is 85 radians per second, angular velocity of link 4 that is 130 radians per second. Similarly, angular acceleration of link 2 that is 0 radians per second square, angular acceleration of link 3 that is minus 1000 radians per second square and angular acceleration of link 4 that is equals to negative sign of 16,000 radians per second square. Using these values, how to find the length of the links for this linkage? We know that the length and angular position of the crank. So this is the equation as we have discussed earlier. Here simply substitute the value of omega 4, alpha 3, omega 3 square minus omega 3, alpha 4 and omega 4 values. Here the meaning of J indicates imaginary terms, real and imaginary terms. While simplifying this equation, be careful. Find the values in terms of real and imaginary. Real and imaginary term. These are the two terms while simplifying this term. Again, further simplification of this, we can get these two. Keep as it is real and imaginary terms. Again, further, add only real terms, then imaginary terms, then we can get this equation. Now, in order to find the actual length of the link 2 and angular position of link 2, Using calci, first press the button shift, then polar. So type 1.23 e power 6 comma negative sign minus 0.4967 e power 6, close the bracket, then press the button equal, then we can get the length of the link 2, that is 1.326 10 power 6. Now to determine angular position of R2, press RCL once, then tan once, then we can get the angular position of R2, that is negative sign of 21.98. So that is, we can see at here. Similarly, to determine length and angular position of connecting rod, so we know the equation, R3 equation. In this, substitute omega 2 value, alpha 4, omega 4, omega 4, alpha 2, omega 2 values. Then simplify the equation, keep in real imaginary terms from these two, then again add only real terms and imaginary terms, then we can get R3 equation. Again, to simplify this, using calci, shift, using calci, first press shift, polar, type R2 value minus 3.2 e power 6 comma, again negative sign, minus 1.82 e power 6, close the bracket, then press equal button, then we get the value of R3, that is positive sign of 3.681 into 10 power 6. Again, in order to determine angular position of R3 with the same value, press RCL button once, then tan button once, then we get angular position of R3, that is with negative sign of 150.37 degree. Next, the length and angular position of follower. So this is the equation. Here substitute omega 3, alpha 2, omega 2 value, omega 2, alpha 3, omega 3 values, simplify the term, finally keep R4 equation in terms of real and imaginary terms. Further, to find the actual length of R4 and angular position of R4 using calci, to simplify this equation, press shift button, polar, 0.2 e power 6 comma 1.955 e power 6, close the bracket, press equal button, then we get the length of R4, that is 1.965 into 10 power 6. Again, to determine angular position of R4 with the same value, press RCL button once, then tan button once, then we can get the angular position of R4, that is positive sign of 84.15 degree. So like this, we can determine the actual length and angular position of R2, R3 and R4. Using the values of R2, R3 and R4, we can determine the actual length and angular position of R1. Here we have to substitute the value of R2, the value of R3 and value of R4 with actual, real and imaginary terms. After substituting the values of R2, R3 and R4, find R1 equation in terms of real and imaginary terms. From the above equation, first add real terms, then add imaginary terms, then keep R1 equation with real and imaginary terms, again using Calc. So find out the actual length of R1 and angular position of R1, similar to previous method. After finding the values of R1, R2, R3 and R4, to construct the 4-bar mechanism, first we have to assume a suitable scale. Here, if we assume 1 centimeter equals 0.5 into 10 power 6 unit, according to this considered scale, convert the values of R1, R2, R3 and R4. For example, here we can see R2 value and its angular position. 1.326 into 10 power 6 divided by 0.5 into 10 power 6. Then the value of R2 is 2.65 centimeter. Then keep the angle as it is. Similarly, R3 equals 7.36 centimeter. Keep the angular position as it is. R4 value is 3.93 centimeter and its angular position, and R1 value equals 3.61 centimeter, then its angular position is 11.6 degree. So using these values, first consider a point, call it as O2. This is one end of the frame. Through O2, draw a line horizontally. This is the reference line. Then as a center of O2, with reference to this horizontal, in counterclockwise, draw a line at an angle 11.6 degree, that is equal to angular position of R1. Then along this path, mark the length of R1. After marking the length of R1 from R2, then we get R4. Then the distance from O2 to O4 is equal to 3.61 centimeter. So this is the frame of this mechanism. Then further, through O4, draw a line horizontally. Again, as a center of O4, with reference to this horizontal, in counterclockwise, draw a line at an angle 84.15 degree. So further, I will select R4 value and its angular position, out of which first we have to take angular position like this. Then along this path, mark the value of 3.93 centimeter. Then we get point A. After getting point A, to find the point B by arc method, as a center of A, select the radial distance equal to R3, that is equal to 7.36 centimeter. Draw an arc. Again, as a center of O2, select the radial distance equal to R2, that is 2.65 centimeter. Then draw an arc. Where it exactly these two arcs will intersect, that is the point B. Then the distance from A to B equal to R3 value. Distance from O2 to B, that is equal to the value of R2. Here also, with reference to the horizontal position as a center of A in counterclockwise, that is the indication, that is in clockwise, that is the indication of negative sign. Again, as a center of O2 with reference to horizontal in clockwise, that is the indication of negative. We can find out angular position of R3 and R2. Like this, we can plot the 4-bar linkage according to the given data.